Hello and welcome to Math with Mrs. Becker. Today in College Algebra, we are getting ready for our Chapter 2 test. This exam covers sections 2.1 through 2.5. Let's get started. The first question, we have n of x equals x squared. Okay, so that is our beginning function. They want us to compare n equals 6 times the quantity x minus 7 squared plus 6. They want us to compare these two graphs. What they're actually asking for are transformations. How did you go from this graph to this graph? Remember, there is a particular order that we need to follow. Step 1, it follows the order of operations. So you always look for any changes within the parentheses first. In parentheses, I am adding or subtracting. In this case, I'm subtracting. But again, anytime you're adding or subtracting in parentheses, it's a horizontal. You can call it a shift. You can call it a slide. You can call it a translation. Okay, they all mean the same thing. So I have a horizontal shift. Remember, the formula is x minus h. Because it's a minus, that means that the 7 that we filled in was a positive 7 because the negative remained negative. Okay, it stayed how it was. So this 7 is positive, so that means I'm going in the positive direction, which is the right 7. Now, the other two changes I see. There's multiplying by a 6 in front and adding a 6 at the end. Order of operations, you multiply first. Anytime you are multiplying, it is a stretch or compression. If it's not in parentheses, it's vertical. So this is a vertical. If I look at the number, it's 6. 6 is larger than 1, so this is a vertical stretch. Last but not least, adding and subtracting is always a translation. It's not in parentheses, so it's vertical. So we have a vertical slide. It's plus 6, so I would be going up 6. So here what happened is they started with the parent quadratic function. They took that parabola, they shifted it to the right 7, then they grabbed the top and bottom and pulled it to stretch it so it was taller and more narrow, then they slid it up 6. When they did that, the new equation would look like that. Okay, let's look at another one. Compare this graph to the same thing. Okay, there are a lot of changes here. So again, make sure that we go right in that order. We're starting with x squared. We end up with negative 1/4 times the quantity x plus 4 squared minus 3. Again, step 1, anything that's in parentheses needs to come first. If you're adding or subtracting in parentheses, that is a horizontal slide, shift, or translation. This time it's a plus. So what that means is I had x minus. They must have filled in a negative 4 when they did this equation because minus and negative is how they ended up with a plus. If we filled a negative 4 in, that means I'm going to the negative direction, so I'm traveling to the left 4. Okay, now I have a negative and a 1/4 being multiplied and subtraction. Multiplication comes first. The number matters more than the sign. So I look at this 1/4 first. Multiplying, not in parentheses, so it's vertical. The number I'm multiplying is 1/4. 1/4 is less than 1, so it's a vertical compression. Now I will look at the negative. Negative is always a reflection. If your negative is out front, what it does is it flips everything upside down. In order to flip everything upside down, it's a reflection over the x-axis. Step 4, okay, the last one, adding and subtracting not in parentheses, that's a vertical slide. I'm minusing 3, so we're going down 3. So what happened here to go from here to here? They took your parent function, the quadratic, and they took that parabola and they shifted it over to the left 4. Then they grabbed it on the top and the bottom and they made it shorter, which actually would make it wider. Then they flipped it upside down and slid it up 3. It was like a roller coaster ride. Crazy stuff. Okay, next part. Write the standard form of the equation of the parabola that has this as a vertex and it passes through this point. Remember the standard form for a parabola. Y equals a x minus h quantity squared plus k. What I need to do is use my vertex and the point so I can find a. Your vertex is HK. Your ordered pair is XY. If I look at that information, I know everything except for A. Y is really a 9. A. X is 4 minus H is negative 6 squared. K is a negative 2. I have a 9 here. A, I'm going to go ahead and simplify this. 4 minus a negative 6, well, that's going to be plus. 4 plus 6 is 10. 10 squared is 100 minus 2. Well, if I add the 2 over, I would have 11 equals A times 100 is 100A. Go ahead and divide both sides by 100. A is 11 over 100. Now, in order to write the equation in standard form, you need two things. You need A and you need your vertex. So let's do this. Y equals A, 11 over 100. X minus the X value from the vertex, so I'm minusing a negative 6. That makes it a positive 6. Don't forget your exponent, minus 2. Here is the standard form of the quadratic. If you graph this parabola right here, its vertex, its lowest point, because remember this is positive, so it's opening upwards. Its lowest point would be located 6 units to the left and 2 units down from the origin. Your parabola would cut through the ordered pair for 9 at some point. Okay, write the equation for F, for the parabola, in standard form if you have a vertex is HK, and X intercepts. So if I go ahead and visualize this, okay, I'm a visual learner, I gotta see this. So I go 1, 2, 3, 4, got a point. 5, 6, got a point. Okay, so what we need to realize, these are our x-intercepts. This is where the parabola is actually going to cross the x-axis. So just for a visual, okay? My vertex is going to be to the left 5 and down 1. So that's what we're dealing with. What they want, though, is the equation. So I need to know a point. Well, they gave us 2 points. I can just go ahead and use one of them. Let's use x-intercept is negative 4 and 0. So this can be my xy because I know my parabola has to go through that if that's one of the intercepts. So it's y equals, we don't know a. X is negative 4 minus h is negative 5, quantity squared, k minus 1. So this is 0 equals negative 4 minus a negative, this will be plus. Negative 4 plus 5 is 1. 1 squared is 1. 1 times a is 1a minus 1. If I add 1 to the other side, a equals 1. So it's going to be a parabola opening upwards, which we figured out here because I looked at that, I'm like, okay, I got to know what this looks like. I hope you kind of are the same way. All right, so I have A. You need A and you need your vertex. They want the equation. Well, we got this. So y equals A is a 1. X minus the X value from the vertex, it's a negative 5. So if I minus a negative, it will become a plus. Don't forget the power of 2. K is a negative 1. There is the standard form for the parabola that would have a vertex of negative 5, negative 1, and it would go through the intercepts negative 4, 0, and negative 6, 0. Okay, this is end behavior. One thing that's really important that you remember, if you have a rational function, okay, fancy way of saying that we have a fraction, okay? If you have a fraction and the bottom is one single term, it's a monomial. I'm allowed to separate this. I can take the top, the middle, and the bottom all over 4. So this is the same thing as like 1/4 x cubed plus 1/4 x squared minus 6 over 4 can be reduced to 3/2 x. That is the exact same thing. I just took each piece separately over the 4. Now, end behavior. Leading coefficient, 3x is 2x is 1x. The number in front is 1/4. Your degree, the degree is a 3. So end behavior, your leading coefficient tells you what happens as you go to the right. As x approaches positive infinity, as I go to the right, our polynomial, it has to match the sign of the leading coefficient. My leading coefficient is positive, so what that tells us is as I go all the way to the right, I'm going to have an arrow going upwards. My degree, as x approaches negative infinity, this just means as I go to the left, my polynomial, because my degree is odd, it has to do the opposite. So if this side was going up, the other side would have to go downwards. Okay, now this is already factored. They want us to find the zeros. Notice we already have the parentheses there, so they did the hard work for us. They factored it. If you have something that is factored and you need to find the zeros, you take each piece separately and you set it equal to 0 and you solve. So I need two solutions out of here. So if I take the square root, x equals plus or minus the square root of 0, which is 0. Well, there's no such thing as a positive 0 and a negative 0. So this is really x equals 0, multiplicity of 2. 0 occurs as an answer twice because there is no such thing as a positive 0 or negative 0. Both of them have a value of 0, so that solution occurs 2 times. Minus 5 minus 5, so x equals negative 5. Here I cannot do the difference of squares because that's a plus. So I go ahead and minus the 64 over. This is a negative 64. To cancel a power of 2, I take the square root. Square root cancels a square, x equals plus or minus. Negative underneath the radical is imaginary. 64, the square root of 64 is 8, so this is plus or minus 8i. So I have two answers from here, positive 8i, negative 8i. This piece had a degree of 1, I have one solution. This piece had a degree of 2, I have two solutions. It's okay that they are both the same value, it's just a multiplicity. Okay, find a third degree polynomial function that has zeros, x equals negative 3, x equals 0, and x equals 8. Now what I want to do is work backwards. So I want all of these so they're equal to 0. If I add 3, x plus 3 equals 0. X equals 0 already, minus 8. X minus 8 equals 0. Whatever's on the non-zero side, I can write it in factored form. So x plus 3, x minus 8 equals 0. Now what I need to do is go ahead and multiply it. Remember, you can multiply in any order. So what I'm going to go ahead and do is distribute this x here. That would make that x squared plus 3x, and I'd have x minus 8 equals 0. Okay, so what I did is I multiplied these two first. One term times two terms, so I distributed. Now I can go ahead and FOIL. First times first. X squared times x is x cubed. X squared times negative 8, negative 8x squared. Inside, 3x times x is 3x squared. Last, 3x times negative 8 is negative 24x. When I go ahead and combine like terms, my final answer would be x cubed. Negative 8x squared plus 3x squared is negative 5x squared minus 24x. Done. Okay, so going backwards. Here's another one. This one's going to get a little bit tougher because we have a conjugate and a square root term. Find a third degree polynomial if its zeros are x equals negative 5 and x equals negative 1 plus the square root of 7. Well, notice that they did not give you all of the zeros. Remember, you can never have an imaginary solution or a radical without having its conjugate. So if negative 1 plus the square root of 7 is a solution, negative 1 minus the square root of 7 also has to be a solution. Now when I go to set these equal to 0, this is one number, this is one number. So I'm putting them in parentheses so I remember that I have to move the whole thing over together. Here I just simply add the 5. So x plus 5 equals 0. Here x minus the group, negative 1 plus the square root of 7 equals 0. Here x minus the group, negative 1 minus the square root of 7 equals 0. Anything that is on the non-zero side goes in parentheses. So I have x plus 5, the group x minus a negative 1 plus the square root of 7, x minus a negative 1 minus the square root of 7 equals 0. Now I can factor this. Now remember, these are conjugates. If you multiply conjugates that have square roots, if you do it correctly, the square root should be gone at the end. So I'm going to go ahead and multiply those. I'm foiling. X times x is x squared. Now when I multiply the outside, this x has to go to the negative 1 and the x has to go to the negative square root of 7. But the negative also goes to whatever's behind it. So this is x times negative of a negative 1. Well, negative times a negative makes it a positive, so x times 1 is x. X times a negative of a negative, so again it's going to be positive. X times a positive square root of 7 is x square root of 7. Inside, one term times two terms, so again we're distributing, but the negative also has to go with. X times a negative of a negative 1. Negative times a negative makes a positive. X times 1 is x. X times a negative square root of 7 is negative x square root of 7. Last, negative times a negative is a positive. What I have remaining is just to multiply these two pieces. I have to FOIL it because it's two terms by two terms. Negative 1 times negative 1 is positive 1. Outside, negative 1 times a negative square root of 7, positive square root of 7. Inside, positive square root of 7 times a negative 1 is a negative square root of 7. Last, positive times a negative is a negative. Square root of 7 times the square root of 7 is the square root of 49, which is 7. Now at this point, if we did everything correctly, we should be able to go ahead and cancel anything with the square root. Positive x squared root of 7, negative x squared root of 7. Positive square root of 7, negative square root of 7. So when I combine the like terms, this is now x squared. 1x plus 1x is 2x. Positive 1 and a negative 7 is negative 6. So I took all of this mumble jumble and it actually broke down to that. Don't forget we still have our x plus 5. I cannot FOIL this because it's two terms by three terms, so I distribute. I need to give every term one more x. So x cubed plus 2x squared minus 6x. Now I multiply every value by 5. So this is 5x squared plus 10x minus 30. Here is our final answer. Combine those like terms. X cubed. This term has two x's. This term has two x's. Combine them. 2x squared plus 5x squared is 7x squared. Negative 6x plus 10x. When you combine them, positive 4x minus 30. Done. All right, hope you guys are having a good time. Turn the page. I know I have a lot here, but I want to make sure I review everything with you. So just stay with me and we'll have a good time. Okay, they want us to sketch this graph. Okay, so sketch it. We're not jumping to Desmos. We're going to go ahead and figure this stuff out through blood, sweat, and tears. Okay, sketch the graph of the quadratic function below. Find the zeros. If I want to find zeros, what I need to do is set it equal to 0. Well, I look at that, I'm like, I don't really want to even try to factor that thing. That could be kind of yucky. I got a 7, which is a prime number. I have negatives everywhere. So right away, I'm like, let's do the quadratic. So A is negative 1, B is negative 4, C is negative 7. So if I go B squared minus 4 times A times C, let's go ahead and calculate it. Negative 4 squared minus 4 times negative 1 times negative 7. Oh, this is a doozy, negative 12. Okay, awesome. I'm so glad I did this. X equals negative B, so it's 4. Plus or minus, now underneath the radical, this is what I have. It's imaginary because it's negative. 12 is not perfect. 12 is 2 times 6. 6 is 2 times 3. So I can cross off two 2's. So it's 2. It's imaginary. Underneath the radical, I cannot cross off the 3. Negative 1 times 2 is negative 2. So I can go ahead, you guys, and check this out. I can divide all of this. 4 divided by negative 2 is negative 2. Plus or minus, the 2's cancel. Now here I'm already including positive and negative, so you would not necessarily need to put the negative there. We could just have I square root of 3, because again, this includes positives and negatives. So that's my solutions. So I can't really graph anything at this point because where it crosses the x-axis, your zeros, they're imaginary. It doesn't really cross. If I want to find the y-intercept where it crosses here, that's where x is a 0. So if I put in a 0 for x, that cancels, I get a negative 7. So 1, 2, 3, 4, 5, 6, 7. Hey, we have a point. Yes, write this in vertex form. Vertex form means I have to complete the square. I have negative x squared minus 4x minus 7. If I'm going from this general form to that vertex or standard form, you separate the x terms from your numbers. Okay, so I put parentheses around the two terms that have an x. I cannot have a value in front of the squared term, so I need to divide the negative 1 out of the parentheses. So that'd be x squared plus 4x minus 7's on the outside. Now that I do not have a value in front of my squared term, I need to find that magic number that if I add it inside here, I can factor. Remember, it's b divided by 2 squared. B is always the value in front of your single variable. So it's 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So if I plug a 4 in there, I will be able to factor this thing. However, I need to make sure that I keep everything balanced. I can't just put a 4 here because now things are not the same value. This negative 1 goes to everything. So when I put a plus 4 here, what I actually did is put in a negative 4. Well, to offset a negative 4, I need to add 4. Okay, so this was a negative 4 because it's tied to that negative 1. If I have a negative 4 and a positive 4, I actually have a value of 0, so I did not change the value of anything. Negative 1, I can factor this. Two numbers that multiply to 4 and add to 4 are 2 and 2. So it's x plus 2 squared. Negative 7 plus 4 is negative 3. That is called the vertex or the standard form. So I'm going to go ahead and write this because I guarantee you we are going to have to refer to it quite a bit as we are coming up. Okay, identify the vertex. Your vertex is the center point. Whatever you're subtracting from x, so here this is x minus a negative 2, whatever you're subtracting from x, that's your x value. Your y value is whatever's at the end. So if I go to the left 2, down 1, 2, 3, that is my vertex, okay? Your axis of symmetry. Remember your axis of symmetry, that is where you have your folding line in the parabola. It always cuts the x-axis. So it's x equals whatever the x value is for the vertex. So here is my center line for the parabola. Will the graph open up or down? Well, a equals negative 1. Negative 1 is less than 1. Remember, if it's a negative value, it's going to open downwards. If your value up front, if a is a positive, it opens up. This is a negative, so it opens down. So I can go ahead and my axis of symmetry is not very straight here. I can graph this. They just want us to sketch it. So I know where it crosses the y-axis. I know where the vertex is. I know where the mirror image is. So this point is 2 units away from the line. So if I go 2 units the other way, I need a point at that same level. So from here, I can go ahead and sketch it. Remember, they just said a sketch, which should open downwards, which it does. This vertex is the highest point, so your vertex is the maximum of the graph. We said that there should be no zeros. Notice that the parabola never does touch the x-axis, so all of those things worked out. Let's move on. Synthetic division. Remember, the rule for synthetic division is x minus h. So whatever value you are subtracting from x, that's what goes in the little box. So this is x minus 5, so it's a positive 5 that goes in the box. Now before you start this process, you have to check and see if you need any zeros. 3x's, 1x's, no x's. Houston, we have a problem. You cannot go 3, 1, 0. We got to put in a 2 there. So I have 1x cubed, no x squareds, negative 75x's, and 250 at the end. You always carry down the first term. Whatever that first term is always just dropped. 1 times 5 is 5. 0 plus 5 is 5. 5 times 5 is 25. Negative 75 plus 25 is negative 50. Negative 50 times 5 is negative 250. Positive 250, negative 250 is a 0. The last number is always your remainder. Next to your remainder is a number. Next would have 1 value. Next would have 2 as an exponent. So number x, 2 x's. So my answer is 1x squared plus 5x minus 50, no remainder. Okay? If x equals 4 is a root of this, okay, Use synthetic division to factor the polynomial completely. So if x equals 4 is a root, what that means is they're not making us list out that entire thing. What we're doing is they're giving us the value. X equals 4 is going to work. 3 x's, 2 x's, 1x, no x's. So 1x cubed, 1x squared, negative 16x, negative 16. Carry down the 1. 1 times 4 is 4. 4 plus 1 is 5. 5 times 4 is 20. 20 minus 16 is 4. 4 times 4 is 16. Positive 16 and negative 16 is 0. So yes, they told us that, but it was important for us to still do this because we have to break it down so we can factor. Here's the remainder, here's the number, here's x squared. So I have x squared plus 5x plus 4. Now what I need to do is go ahead and factor this. Two numbers that multiply to 4 and add to 5. Well, that's positive 4 and positive 1. 1 times 4 is 4. 4 plus 1 is 5. So if I'm finding my zeros, you take each group separately and set it equal to 0. Here I would minus 4, so x equals negative 4. Here I'd minus 1, so x equals negative 1. My original problem had a degree of 3, so at the end we need 3 solutions. So that's what you do if they give you a solution. Rather than having you list out all of the possible answers and do trial and error, they told you, hey, 4 is going to work, start with that. Then you will be able to factor. Okay? Complex number, a plus bi. So what you have is a real part being added or subtracted to an imaginary part. Negative 15 plus. Negative underneath the radical, this is imaginary. Square root of 49 is 7, so this is 7i. Done. Write the complex conjugate of the number. Remember, complex conjugate means you keep the first term the same, you keep the second term the same. You change the sign in between. So if they want you to write the complex conjugate, all you're doing is changing the sign in between. Simplify this. So they want us to FOIL complex numbers. Write the answer in standard form, which just means that you have your real number in front of your imaginary number. Positive 3 times negative 4 is negative 12. 3 times 10i is 30i. I times negative 4 is negative 4i. I times positive 10 is positive 10i squared. Anytime you have I squared, it's actually a negative 1. Positive 10 times negative 1 is negative 10. When I combine like terms, you always combine the real parts first. Negative 12 combined with a negative 10 is negative 22. Positive 30 and a negative 4 is positive 26i. So our final answer would be negative 22 plus 26i. If you have a quotient with an I on the bottom, you cannot leave the I on the bottom because I is actually the square root of a negative 1, and you can never have a square root on the bottom. So what we have to do is multiply top and bottom by the conjugate of the bottom because I'm trying to cancel the I in the denominator. So 6 minus I. So on the top when I FOIL, negative 7 times 6 is negative 42. Negative 7 times negative I is positive 7i. 5i times 6 is 30i. Positive 5i times negative I is negative 5i squared. I squared is really negative 1. Negative 5 times negative 1 is a positive 5. So the top, I'm grabbing a separate sheet of paper here. Okay, so the top of this, negative 42, and I'm adding 5 to it. I have negative 37 plus 7i plus 30i is 37i. Now the bottom, when I go ahead and I FOIL these, because they're conjugates, the I should cancel. 6 times 6 is 36. 6 times a negative I is a negative 6i. I times 6 is a positive 6i. Positive I times negative I is negative I squared. I squared is really a negative 1, so negative of a negative makes that a positive 1. The middle two terms cancel. 36 plus 1 is 37. If you can divide all of these values by the same thing, which we totally can, you do. Negative 37 over 37 is negative 1. Plus 37 over 37 is 1i. So our answer there is negative 1 plus I. Awesome. Here we go. They want us to find the zeros by factoring. Remember, if your exponents are 4, 2, and 0, you can still do multiply, add, okay? I am multiplying to negative 27, adding to 6. So that's 9 and negative 3. Because 9 times negative 3 is negative 27. 9 minus 3 is 6. Because the x values or your exponents are doubled, when you write this in factored form, you also double the amount of x's you have. I cannot simplify this any further. Yes, these are perfect squares, but it's a plus sign in between. This is a minus in between, but that's not a perfect square. So if I'm finding my zeros, I need to go ahead and take each piece separately, set it equal to 0. Here I would minus 9. So x squared equals a negative 9. Take the square root of each side, so x equals plus or minus, because I cancel the power of 2. Negative underneath the radical, so it's imaginary. Square root of 9 is 3, so it's plus or minus 3i. Here I need to add a 3, so x squared equals 3. Take the square root of each side, so x equals plus or minus square roots of 3. So I have 4 answers. Positive 3i, negative 3i, positive square root of 3, negative square root of 3. That's perfect because we needed 4. Find the zeros using the rational root theorem. Rational root theorem is P over Q. P is the constant at the end, so negative 60. Q is the leading coefficient. Because this is a 1, what I'm doing is finding all of the factors, what I can divide negative 60 by and not get a decimal. Plus or minus 1, 60 is divisible by 2, 60 is divisible by 3, it's divisible by 4, it's divisible by 5, it's divisible by 6. 7, nope. 8, nope. 9, nope. 10, yep. Okay, so here's our partner trick. 6 times 10 is 60. So the next value is what goes with 5 to make 60? That's a 12. What goes with 4 to make 60? 15. What goes with 3 to make 60? 20. How about a 2? That's 30. And last but not least, 60. So here are my possible solutions. Now what we need to do is start doing synthetic division to find some solutions. 4x's, 3x's, 2x's, 1x, no x's. Okay, so I don't have to add in any zeros. 1, negative 3, 6, 2, negative 60. I like to start off with a 1. What we're doing down here is just trying any of these numbers until we get something to work. Carry down the first term. 1 times 1 is 1. 1 plus a negative 3 is negative 2. Negative 2 times 1 is negative 2. Negative 2 plus 6 is 4. 4 times 1 is 4. 4 plus 2 is 6. 6 times 1 is 6. Negative 54. Okay, if I remember right, I hate to do this, but I'm going to guess. I think it's a 2. I'm trying it. Okay, drop down a 1. 1 times 2 is 2. Because remember, you don't have to go in any certain order. 1 times 2 is 2. 2 plus a negative 3 is a negative 1. Negative 1 times 2 is a negative 2. Negative 2 plus 6 is 4. 4 times 2 is 8. Nope. 8 plus 2 is 10. 10 times 2 is 20. So it's negative 40. Okay, let's try negative 2. Carry down the 1. 1 times negative 2 is negative 2. Negative 2 plus negative 3 is negative 5. Negative 5 times negative 2 is positive 10. 10 plus 6 is 16. 16 times negative 2 is negative 32. Negative 32 plus 2 is negative 30. Negative 30 times negative 2 is a positive 60. That's a 0. So we do have one solution. X is a negative 2. We got to do it again. Okay, so X is a negative 2. When I look, what I have left, this is a number, this is x squared, this is x cubed. So I have 1x cubed minus 5x squared plus 16x minus 30. I need 3 more solutions. Yes, this has 4 terms, so technically it's a possibility to group. If I look at those two, I could take out 2 x's. Well, it'd be x minus 5. I can't make that x minus 5. So I need to go p over q again. So it's negative 30 over 1. I can divide by plus or minus 1, plus or minus 2, plus or minus 3. 30 is not divisible by 4. Plus or minus 5, plus or minus 6. 5 times 6 is 30. So the next one goes with 3, so it's a 10. Then with 2, so it's a 15. Then with 1, so it's a 30. So here's my possible answers for this polynomial. I'm going to go ahead and start another table. 1x cubed negative 5x squared 16x minus 30. Now here's the deal. Up here, we already tried a 1 and that didn't work. We already tried a 2 and that didn't work. The first time I got an answer was negative 2. I'm trying negative 2 again because you know what? We might have a multiplicity. I like to start where we ended off. Carry down the first term, 1. 1 times negative 2 is negative 2. Negative 2 plus a negative 5 is negative 7. Negative 7 times negative 2 is positive 14. No, 14 plus 16 is 30. 30 times negative 2 is negative 60. Doesn't work. Okay, let's try 3. Carry down the 1. 1 times 3 is 3. 3 plus negative 5 is negative 2. Negative 2 times 3 is negative 6. Negative 6 plus 16 is 10. 10 times 3 is 30. 30 plus a negative 30 is 0. Okay, we got another answer. Okay, so see, even for me, you guys, there's no way to tell what the number is. You just got to keep trying them. And don't be discouraged if you have to try quite a few numbers, okay? Granted, we didn't try that many, but like here, if I would have gone positive 1, negative 1, positive 2, you still would have had it by the fourth one. But I know, I get the same feeling. You look at that, you're like, no, I gotta do it again. So you're not alone, okay? But we're almost there. So this is my remainder, this is my number, this is x squared. So I have x squared minus 2x plus 10. Numbers that multiply to 10, 1 times 10 and 2 times 5. There's no way to make those multiply to 10 and add to negative 2, so I get to do the quadratic. A is 1, B is negative 2, C is 10. So it's b squared minus 4 times a times c. If I go ahead and calculate that, negative 2 squared minus 4 times 1 times 10, I get negative 36. So underneath the radical, it's a negative 36, negative, so it's imaginary. Square root of 36 is 6, so it's 6i. So x equals negative b, so it's positive 2, plus or minus 6i all over 2a. A is a 1, so it's 2. So here are your other solutions. 2 divided by 2 is 1, plus or minus 6 divided by 2 is 3, so it's 1 plus or minus 3i. We needed 4 solutions. We have them. Negative 2 is a solution, positive 3 is a solution, 1 plus 3i is a solution, 1 minus 3i is a solution. Last question. Explain what multiplicity means in terms of graphing. If you have a multiplicity of 1, what that means is the graph crosses the x-axis as a straight line. Okay, so that's what the multiplicity of 1 means. Anytime you have an answer that occurs only once, when you look at the graph, that graph is going to cross the x-axis at that value as a straight line. If you have an even multiplicity, so 2, 4, 6, 8, any even number, your graph is going to bounce off the x-axis at that value. It is not going to cross it. It's going to hit at that value and bounce off the way that it came. If you have an odd multiplicity greater than 1, because 1 we already know. 1 crosses the x-axis as a straight line, but if you have an odd number that's bigger than 1, it bends as it crosses the x-axis. Okay, so what that looks like, let's say that my value is right here. As it crosses, it's going to have a definite bend. So again, if it has a multiplicity of 1, crosses as a straight line, even multiplicities don't actually cross, they bounce. Odd, they do cross, and where that cross occurs, they bend. You guys, that was a full review of the chapter. Sorry the video got a little bit long, but I hope you feel prepared for the exam. Talk to you soon.